Welcome to online tutorial of totally integrated automation. Here in this video we will discuss torque control of slip ring induction motor with the help of S7-1200 PLC. Initially all contactors are open. To start motor K1 line contactor should be closed. Now you can see all rotor resistance are in series, means high starting torque. After 5 seconds K2 contactor closes, which means R1 resistance is being removed by this action. Now after 10 seconds K3 contactor close. This step removes R1 and R2 resistance from the motor. On 15-second K4 contactor get closed, means all resistances are removed. This result less starting torque but high linear speed. Here is wiring of PLC. Input, that is switches, are connected on the left side and outputs on the right. Logic in the PLC determines its operation. Now come to programming part. Start TIA by clicking the icon. You can see the portal view. Create new project, that is starter control. Move to project view. Add new PLC. Select S7-1200 14 DC supply, DC input, DC output. My PLC has analog output signal board. It should be same in software and actual hardware. Define symbol table. Enter input symbols. In Siemens, Q stands for output. M stands for memory. To store numerical value, use word or integer value as data type. Integer value is for positive and negative value. In this program we need system and clock memory bits. From system memory bit we need first scan cycle to initialize all our contactors to reset position. From clock memory bit we need 1 second pulse at the moment. Just remember first scan and 1 second clock pulse. I will explain how to use it in program. Now look at the updated symbol table which has new entries. Here you can see first scan is M1.0. And 1 Hz, that is 1 second clock pulse, is generated on M0.5. Answer this to continue and then double-click on Submit button. Now move to Program part. Change it to Functional Block Diagram FBD from Ladder. Later I will show you this program in Ladder also. For more view space, remove tag and network comment from display area. Put title of the main program block as starter control. Network heading should describe the function of that network. Select favorite button to show favorites on the top of the main title. Select mostly used symbols in favorites. Network 1 will initializes all our contactors to reset position on start of our PLC using first scan cycle. In Network 2 process of starting the motor by pressing on button, it will close his contacts of K1 contactor. In Network 3, when K1 line contactor is closed and K4 contactor is open, generate pulse on rising edge of 1 Hz signal, that is 1 second. Pulse is generated on M2.0. In Network 4, counter get reset on start of the PLC, that is first scan, or on closing of K4 contactor. M2.0 pulse from Network 3 increments the counter on every second. Numerical value of counter is stored in MW10. M2.1 gets set when counter reaches 15. In network 5 we have used comparator when MW10 value is equal to 5 it closes K2 contactor. Let's make it integer looks more good in data presentation as you can see in input 2. In network 6 when MW10 value is equal to 10 seconds, it closes K3 contactor and open K2 contactor. In network 7 M2.1 is set when counter reaches its preset value that is 15. It closes K4 contactor and open K3 contactor. In network 8 if I0.0 is off or F2 over current release button I0.2 is on. Reset all contactors from K1 to K4 and digital value of counter to 0. It is possible to convert the whole program in ladder logic from functional block diagram. Let's see more networks by zooming out. Now zoom in to have more clear picture. Back to FBD. Now save the project. Compile it for error. Select the PLC. And then download it. Select type of PC interface PNIE as shown. My PC interface is Realtek. It may differ in your case. If there is problem in downloading it, then check your PC IP address as shown in our previous video underground car parking project. It should be in same subnet mask. Answer these 3 questions to continue. Click on Online Monitor to view actual position in PLC. Click arrow for larger view. Here you can see synchronize hardware and software view. Start the motor by I0.0 and I0.1. In network 3 1-second pulse is generated by M0.5. Counter is incremented to 15 and then get reset from K4 starting contactor. Program is repeated again to have more clear picture of contactors in operation. Now switch off the motor. Thanks for watching this video. Please subscribe us for more videos.